Unit testing is a development practice used to safeguard our expectations from the behavior of our code. As part of the development process, developers write their code with a specific intent in mind, based on the given specifications and requirements. Once the code is written, it has to be executed and we have to ensure that it works as expected. Usually, developers do this manually by using logs or the debug function in order to track and evaluate execution steps and make sure that the outcome of the execution matches our expectations and intent. However, the larger the project gets, the more time-consuming and complicated this process becomes. Imagine having a project of hundreds of thousands of lines of code, encapsulating hundreds of functionalities for which we need to make some changes. After the changes are complete, we would have to verify by hand all the features just to make sure we have not altered or broken anything through the changes we made. This is where unit testing comes into play. Instead of manually checking our code every time a change happens, we can write execution scenarios that evaluate the outcome of specific pieces of code and automatically run these scenarios anytime we want and as many times as we need, with little or no effort. When it comes to testing scenarios, it is important to understand the scope and size of the code we are testing. Of course, we could just test each main feature, by providing a correct, controlled input and evaluate the output of the specific functionality. This would tell us if the functionality behaves as expected, or it has suffered some changes and the output no longer matches our needs. While this is useful in itself, it does not bring additional value outside of the fact that it tells us if we broke something or not. In order to increase the value of this practice, we would need to be able to identify the actual point or points in our code that no longer behave as intended. As the name suggests, unit testing is better suited to test small units of code, which usually refer to methods in our code. Writing testing scenarios for each method would immediately pinpoint the methods that no longer work as expected when changes occur. Another relevant aspect when evaluating the outcome of our code, especially in the context of testing units of code, is that our methods might call other methods from other classes or modules in our project, and their behavior might be influenced by these dependencies. Assuming that other units of code are also correctly tested, we would need to isolate our code from its dependencies in order to ensure that we are only testing each specific unit and its independent behavior. This is called testing in isolation, and it implies that we only evaluate unit-specific behavior while assuming that dependencies work as intended. By applying this property to unit testing, when a testing scenario fails, we know exactly what method in our code is broken, thus significantly simplifying the repair process. Finally, unit testing also provides the direct benefit of helping developers evaluate their actual work. Different testing scenarios, with different, controlled inputs should provide specific expected results, regardless of the logical branches executed in our code. This practice helps developers discover parts of the code, especially in complex methods, where the implementation might be wrong or incomplete. Since unit testing evaluates expected behavior based on given input, it becomes much easier to discover those parts of our code that do not behave as intended. The practice of unit testing is not new, with some of the pioneers of programming and computer science writing about the necessity of testing code since the 1960s. In the 60 years that this practice has been around, it has been improved, enhanced and refined to a standard approach, currently widely used by most software development companies. As part of the standard development process, unit testing was also found to provide additional advantages to software development aside from safeguarding behavior. During the lifetime of any project, it is normal that some features or at least some parts of the code base will become obsolete, deprecated or outdated, because specifications or requirements change or because newer, better libraries are released. Regardless of the situation, old code needs to be refactored. Correctly safeguarding existing code through unit tests makes refactoring much easier, as any change can be immediately evaluated, reducing the risk of unwanted behavior or mistakes being introduced in the refactored code. As such, unit testing greatly reduces the cost of change in software development processes. Another indirect benefit of unit testing is that it forces developers to write better, smarter code. For example, a method that does too many things, breaking the single responsibility principle, is also very difficult to test. When developers find themselves in the situation where writing a unit test for a method is extremely complicated and time-consuming, it also means that the method they are testing is not implemented in accordance to development and clean code practices. As such, unit testing also encourages correct and efficient development practices. While unit testing provides some relevant and valuable benefits, there are also some potential issues we need to consider. First of all, unit testing can also be done incorrectly. Some of the most common problems when writing unit tests are related to the way the test scenarios are modeled, the way the code of the unit tests is written, and what the tests actually evaluate. As such, unit testing needs to satisfy a series of properties in order to be correct and relevant. We also need to consider that unit tests are also part of the codebase and, as such, they need to be written in accordance to all development principles and standards used in software development. Secondly, unit tests need to address a single unit of code, usually a class method, isolated from any external dependencies and decoupled from environment properties or external data. Unit tests need to be repeatable, in the sense that any test can be run any number of times, decoupled or as part of a test suite, on any environment without the need for extra configuration or code management. Tests need to be deterministic, meaning that for a specific input, a unit test will always perform in the same way and produce the same outcome. Unit tests also need to be predictable in the sense that input data and the expected output need to be explicitly defined, and there should not be any unwanted or unexpected side effects related to the way test data and the expected output are created and managed. Finally, unit tests need to be really fast as to encourage developers to run the tests frequently, after small changes occur, in order to discover issues in the code as early as possible. Until now, we discussed the benefits of unit testing, but there are also some downsides to this practice. First of all, unit testing requires extra effort to be done correctly and also require more code to be written, directly increasing development and delivery time. As such, when estimating the effort for a specific task, developers also need to take into account the effort and time required for proper unit testing. Unit tests, as part of the project code base, also suffer from the risk of becoming obsolete or deprecated and, as such, also require extra effort for code maintenance. No matter the level of experience and the effort put into unit testing, this practice cannot identify or prevent any and all possible bugs and issues in our code. Other practices, related to software testing and quality assurance, need to be employed, in order to identify and reduce the number of issues in the final deliverable software product. Finally, investing too much effort into unit testing, for example over-engineering our tests, might lead to unwanted side effects related to the overall design of the software system. It is possible that developers overly focused on facilitating and simplifying unit testing might inadvertently write code that is not aligned with the required system design or the correct development practices, but that is just easier to test. As such, code review, performed by other members of the team, is usually recommended as a way of evaluating the delivered code and the associated unit tests.